Sambo. My name is Suresh Rai and I am in 4th year civil. During this time of the year when people all around the world are trying to fight with COVID situation, I hope people in Bhutan are trying to stay safe and follow the protocol of COVID and also live with the expectation of His Majesty. Today we are going to demonstrate our earthquake resistant model. Before that, what is an earthquake? An earthquake is a tremor or movement of the earth crust that originates from below the surface, and there is no possibility that earthquake can be prevented. The earthquake has occurred in different parts of the place with different magnitude and has caused damage to the lives and properties of the people. So it is important as a civil engineer that we try to create the structures that are more resistant to the earthquake. Thus, today we are going to demonstrate two concepts that will make our structure more earthquake resistant.
For example, I am Sabina Nepal and I will be explaining the mechanism of our model. We all know that earthquake doesn't kill, but the building that collapses does. So what can we do in order to save lives? Being a civil engineer, we can look for techniques that can minimize the collapse. There are many techniques such as use of base isolators, dampers and shear wall that can help minimize the building collapse. The main aim of our demonstration today is to test and compare the structure with base isolator and shear wall can perform better than the structure with just base isolator while resisting the seismic force. And also we will be demonstrating that structure with shear wall will perform better than structure without shear wall in absence of base isolator. To test this properly, we have built a shake table. Firstly, I will be explaining the principles involved in this model. So, as I mentioned above, we have used shear wall and base isolators. Shear walls are basically vertical wall-like plates in addition to beams, columns and slabs. Base isolation is basically separating the building from the ground by using a shock absorber in between the ground and the building. Before demonstrating the working of our model, I'll be explaining the components involved in our model. So firstly, the 4-storied building frame has been made using wood and the beam to column connection has been done using nails. After that, we have adopted plywood as our shear wall material, and then from the 6 major types of isolators available, we have adopted the spring type isolator. So here spring type isolator will act as a shock absorber which will separate our building from the ground. Here the upper plywood will be separated from the lower plywood using the spring. After that, we made the shake table using the housing and motor of the fan. We will be demonstrating in 2 phases. In the first phase, we will demonstrate with base isolation, and in the second phase, we will demonstrate without base isolation, whereby the screw here will be tightened, which will disregard the function of this spring. As you all know, earthquake forces primarily act in 2 directions, but in our demonstration, this motor induces movement only in one direction. So we have restricted movement only in one direction using this plywood. Now it's turn to test our model on the shake table.
This demonstration displays the deflection of frame in absence of base isolator. Here we can notice that the frame without the shear wall, which is in the left, deflects more compared to the one in right. Hence it is evident that building with shear wall can effectively resist earthquake force. As we all know, Bhutan experiences a lot of earthquake. We can adopt shear wall in order to minimize the probability of building collapse. Now in this demonstration, we can notice that both the frames do not deflect in presence of base isolator. Hence we can conclude that in presence of base isolator, effect of shear wall is not significant.
Hello everyone, I am Sunam Chizom. To conclude the demonstration, we have concluded with the base isolator, building frame with the shear wall and without shear wall is deflected by the same amount, and without the base isolator, building frame without the shear wall deflects comparatively more with respect to the building with the shear wall.